Hello everyone, welcome once again to your junior high school hour on your Joylearning channel. My name is Lord Apiadam and I come your way again with your math lesson for today. Today we are looking at linear equations. We are looking at linear equations today. And I'm very sure that this is not the first time you are hearing this. Some of us are familiar with this already, but some of us are getting to understand it. And some of us do not even have an idea of what it is. But by the end of today's lesson, I'm very sure that you all come together to understand what linear equation is about. So without much ado, let's look at what it means. So before we talk about a linear equation, now let's get to understand what an equation is. So when we say an equation, okay, it's a term we normally use, but what then is it? What's an equation? So we say an equation is a mathematical statement, okay, that expresses or indicates that two expressions are equal in value. It's a mathematical statement. So what you have is you have a statement on the left hand side and you have a statement on the right hand side, and they are being joined together by an equal to sign. Okay, so you might have maybe 4x plus 2 is equal to 20. So what the equal to sign indicates is that those two, the expression on the left hand side and the one on the right hand side are equal. So that's basically what an equation is. So like we have on our screen, so the left hand side, the statement on the left hand side should be equal to the one on the right hand side. Okay, so with that we have an equation. So basically a statement that has an equal to sign within. Okay, so that being said, let's look at what a linear equation is. We know an equation is a statement that has an equal to sign in, which indicates that the left hand side and the right hand side expressions are the same. Now a linear equation is a type of equation, okay, where the unknown value, being represented by a variable. Okay, so the unknown value is normally represented by a variable. We've already discussed what a variable is. It's raised to only the first power. So the unknown value is raised to only power 1. So you may have maybe 5x plus 11 equal to another number, 20x, not a situation where you have maybe 20x squared or 20x cubed. So in this case, what makes a linear equation is the fact that the variable, which in our case is the x, is raised to only 1 power. Okay, so that makes it a linear equation. So the type of equation where the unknown value that's represented by a variable is raised to only the first power. So it's expressed generally as this, like what we have in our screen. On our screen, generally it can be expressed as ax plus b equal to 0. Okay, so don't be deceived by the a and the b you see here. They are constant. Okay, so the a and b we see here are constant. So they can represent any known number that we can talk of. So where a and b are constant and a is not equal to 0. So for it to be called a linear equation, then a should not be 0, because if a is 0, then the expression as then goes to 0. Okay, the expression as goes to 0, and then it doesn't satisfy the condition for it to be a linear equation. You get it? So what it is a should have a positive, or let's say it has to be an integer. So it could be a positive or negative value, but then it should not be equal to 0, so that we get the x is able to stand with its power as 1. Okay, plus b equal to 0. So an example that we have here is 3s plus 12 equal to 0. So 3s plus 12 equal to 0. This is an example of a linear equation. It could also be expressed as 3s equal to negative 12. Okay, we will get to understand why it is so. So 3s plus 12 equal to 0 is an example of a linear equation. Okay, so normally with linear equations, what you do is you're supposed to find the missing value, okay, which is being represented by a variable. So that's normally what we do when we are dealing with linear equations. So we have 3s plus 12 equal to 0. So if you want x, there's a way to go about it to get the value of x, so that the value of x will satisfy the equation to make it correct, okay, or to make it accurate. Okay, so that's what we'll be doing today. Okay, so let's take a quick look at some examples and how to solve them. So we have solve for m in the following. So solve for m. We have 4 questions here. We have 5m plus 7 equal to 67. That's number 1. Number 2, we have 7m minus 5 equal to 100. Number 3, we have 32 minus 3m equal to 5. And number 4, we have 17 minus 4m equal to negative 11. So in all these questions, you are supposed to find a value for m, which will make the equation, or which will satisfy the equation. Okay, so a value for m which, when replaced with a variable, the equation will be correct. So let's look at how we go about it. So let's look at the first question. Okay, so we have, for number 1, we have 5m plus 7 equals to 67. So it's quite a familiar grounds for most of us. But nonetheless, let's go through it again. So we have 5m plus 7 to give us 67. We want the value of m. Okay, we want the value of m that will make this equation actually accurate, or you make it true. What we do is we have to make m stand alone. Okay, so in order to do that, we first send the 7 to the other side. Okay, so we have, let me repeat it again. So we have 5m plus 7 equals 67. Then what you do is we send this 7 to this side of what? The equal to sign. We are aiming to make m stand alone. That's our aim. Okay, our main objective. You want m to stand alone. But then everything around m has to leave. Now the first thing that has to go is with the plus 7, because it's not really attached to the m, or it's not that close. So when we deal with this, then we come and deal with this. So the plus 7 moves to the side. But the reason why I keep on saying plus 7 is because the 7 is carrying the sign in front of it. Okay, every number carries a sign in front of it. So this 5 carries an imaginary positive sign in front of it. Unless negative is here, every number is for positive. So this 7 goes here and then it goes with this sign. So we have plus 7 moving here. We are left with 5m on the left hand side of the equation. Plus 7 moves, so you have 67, which is already there, and then plus 7 becomes what? Minus 7. Then we are left with 5m equal to 60. That's 67 minus 7, giving us 60. At this point, you have 5m, you have 60. You want m to stand alone. The only way we can do that is to divide both sides by 5. Okay, in so doing, the 5 will cancel out the 5, and then we have what? The value of m over here. So we have 5 over here, then we have 5 over here. This will cancel out this. We have m equal to a 60 over 5. So we look for a way to divide this, and then 5 into 60, we get our final answer to be 12. So our value for m over here is what? Is 12. Okay, that becomes our answer for the first question. So if you have to put 12 into this equation, we should get back our 67. We can try that. 12 times 5, we get 60. 60 plus 7, we get back our 67. So that's it for the first one. Okay, now let's quickly take a look at the second one. So that's it for the first question. That's 5m plus 7 equals to 67. We have our m to equal to what? 12. Now the second question goes, so we have 7m minus 5 equal to 100. 7m minus 5 equal to 100. So very similar to the first one. We want m to stand alone, so everything around m has to move, starting with what is here. Okay, we have 7m minus 5 equal to 100. Now negative 5 is what is here. So you want it to move to what? To this side of the equation. That's the right hand side. It goes here, we have 100 already there. The negative becomes positive. Okay, and then the 5 comes. So we already know this, that when a sign crosses the equal to sign, when an operation sign crosses the equal to sign, it becomes the opposite of its value. Okay, so if it's negative, it becomes for positive. If positive, it becomes for negative. If it's multiplying, it comes to divide. If it's divide, it comes to multiply. So it plays its opposite role when it crosses the equal to sign. So that being said, we know that negative 5 becomes for positive 5 over here. Then we have an equation like 7m equal to 105. At this point, we want m. So what we do is we divide both sides by what? What is multiplying the m? In this case, it's 7. We divide here 7 by 7, then 7 by 105. So 7 to 105, we get 15. We get 15 for that. So 15 over 1. So m is equal to what? 15. Okay, so our m value over here is what? 15. If you have to put this 15 here, you multiply by 7 back, you get 105. You subtract 5 from it, you get 100. So the value for m in the second question is what? It's 15. Now let's take a look at the other questions. Now for question 3, 32 minus 3m equal to 5. Okay, so this is what we have. Okay, so this is where it gets a bit tricky for us. Now at this point, ideally I would advise that you make sure you get a positive sign for m. Okay, so with that, rather than sending the other number to the other side, okay, rather than sending the other number to the other side, I rather send m, okay, the value or the expression containing m to the other side, so that I can get a positive value for what? M. There are actually two ways of doing it. So I think I will do the other way so that we get we can choose from which will help us the best. So let me do the first one here, then I do the second one here. So for the first one, I will send a negative 3m to this side, leaving 32 over here. 32 equal to what? 5 plus 3m. Though it's a bit longer. Okay, so 5 plus 3m. Because the 32 is here, I've sent a negative 3 to this side. So the 5 was already there. That's what I have here. The negative 3 has moved and has become a positive 3m. Okay. Now at this point, even though this is, let's say, the stranger over here, it has still come to sack this, because ideally we are looking for him. So everything around him has to move. So the 5 will still move back to the side. Okay. We could have done it concurrently, but then that will be a bit fast on the eyes of some people. So let's do it slowly. And then the 5 moves here. We have 32 minus 5, giving us what? 3m. The positive will not be important to indicate because every number is positive. Okay, every number is actually positive. So the plus over here is imaginary. Okay, it's actually there. So this will leave us with 27 equal to what? 3m. At this point, you can divide both sides by 3, and by 3 we have m equal to what? 9. So our value for m is what? It's 9. If you have to put in 9 over here, we should get our answer here. Okay, now the other way of doing it, so that is the, I should say, a bit conventional way. So with this, you send a 32 to the other side, okay, like we are doing it for the first two questions. So what we get is negative 3m. Like I said, the negative is for the number after it, or the number, every number takes the sign that precedes it. Okay, so in this case, the negative is for what? The 3m. Equal to what? 5. If the 32 goes to the other side, okay, it's positive over here, so it becomes negative. So 5 minus 32. That will give us an answer like negative 3m equal to 5 minus 32. Now this becomes a little bit challenging. If you're not very good with your integers, you might find yourself wanting over here. So that's why it's a little bit more advisable that you take this route where you have a positive value for m. But then let's go on. So 5 minus 32, we have negative 27 for that. And at this point, we divide both sides by negative 3. Not just by 3, because we want m, we don't want negative m. So if you divide both sides by 3, you end up having negative m. And that's not what we are looking for. We have to find m. So we divide both sides by negative 3 and negative 3. So this cancels out this. And then negative cancels out negative. So most of the times people may forget to do this. So the more reason why you revert to the other way. So negative cancel out negative, 3 cancel out 27 9 times. So you have m equal to what? 9. So they both give us the same answer, but they are different roots. But then, just like I said, I would prefer that the m carries a positive sign. Okay, when the m carries a positive sign, it's easier to work with it. Though there are some cases that you'll be forced to deal with the negative sign, but until we get there, I think we should handle it this way. Okay, though you come out with the same answer, this takes a more risky route. Okay, so we can move on to the fourth question. Okay, the fourth question that also has a similar look like the third one. So for the fourth question, we have 17 minus 4m equal to negative 11. 17 minus 4m equal to negative 11. So we want m. Okay, so like I was saying, I would rather send the m to the side so that I get rid of the negative sign. So what I'm left with is 17 equal to what? So the 11 is already there. So 11 negative becomes what? Positive. So 11 plus 4m. That's what I have. At this point, I can move the 11 to this side, giving me 17 minus 11 because it's possible. Sorry, is it negative? It's negative 11 actually. Okay, so equal to negative 11 plus 4m. So 17 minus 11, the negative moves and becomes a positive. Plus 11 equal to what? 4m. So you have 17 plus 11 equal to 4m. And that will give us 28 equal to 4m. Now one thing you should notice, the m could be on either side of the equal to sign. It doesn't necessarily have to be on the left hand side. if it's on the right hand side, it still means that it's equal to this. Okay, so anywhere you find it, it shouldn't be a problem. Okay, so at this point, you divide both sides by 4. So the 4 cancels out 4 over here. 4 cancels out 28 7 times. So we are left with 7 is equal to m. So then our value for m, yeah, over here is what? It's 7. So that's for the fourth question. Okay. Now we can look at some other examples. Okay, some other examples still under linear equation. This time we are looking for x, but we realize that for the next examples, from 5 to 7, we have the same variable on both sides of the on both sides of the equation sign. So let's look at a way of doing this. So let's get number 5. So this time we are looking for x. Number 5, you have 5x minus 2 equals 8x minus 7. So this is what we have for number 5. In solving this, what we do is we group like terms. Okay, so all the variables move to one place and all the letters move to one place. So that's the very first step we take. We have to group like terms. Okay, all the expressions containing the variables should move to one side, and all the numbers, okay, all the constants should move to the other side. So what do we have? We can send 5x over here. Okay, then we bring negative 7 over here. So this time around we will do it concurrently. Okay, let's just do it slowly so that we have everyone catching up. So let's send the 5x to the side. Okay, we have negative 2 over here equal to what? 8x minus 7, then minus 5x. So this is what we have. Okay, so you send the 5x to the side. Now it's time to send a negative 7 to the side. Okay, because we want all the x's to be on one side and all the constants to be on one side. So we have negative 2 over here already. So I think our integers will really come to play when you are solving this, because if you don't know how to deal with adding negative and positive numbers, you find yourself in a situation when you're trying to solve the question. So we have negative 2 here. Negative 7 moves here and becomes what? Plus 7 equal to 8x. Okay, 8x minus 5x. So the minus is for 5x. This negative 7 has moved. We have a negative 5x coming here. So here we have negative 2 plus 7, giving us positive 5. Okay, so 5 equal to 8x minus 5x, that is what? 3x. Okay, so we already know how to subtract expressions containing variables. So at this point, you want x, we divide both sides by 3. We divide this side 2 by 3. So this will cancel out this. We are left with x equal to 5 over 3. So then our value for x for this equation is what? 5 over 3. What it means is if you are to put in 5 over 3, wherever we see x, the equation should stand. Or the expression over here should be equal to the expression over here. So that's it for the fifth one. So the first step is what? We group all the like terms at one side, and then we move all the unlike terms to the other side, and then we go ahead and do the calculation. Now let's move to the sixth question, where we have 3x plus 1. So we have 3x plus 1 being equal to 2x plus 5. So 3x plus 1 equal to 2x plus 5. Okay, so this time around, I'll move the 2x this way. Now, the idea behind this is I want to end up having a positive sign for the x. Okay, so if they are both positive, I'd rather move the smaller number to the bigger number, so that at the end of the day, then after the subtraction, I still have a positive sign. Okay, so I bring the 2x to the side. I have 3x plus 1 plus 2x. It be equal to what? 5. That's positive 5 over here. Then I bring the 1 also to the side. Okay, we have 3x plus 2x. Because the 1 is no more there, we have equal to 5 minus 1. It's positive, it becomes a negative over here. Okay, so sorry, I think, yeah, at this point, the 2 was positive. So once it crosses the equal to sign, it becomes negative. So we have 3x plus 1 minus 2x, and then minus 2x over here. Okay, so the 2x has crossed and become what? Negative. So we have minus 2x, and the same thing over here. So we have 3x minus 2x, and that will give us what? 1x But 1x can be expressed as what? X. So in this case, we have our x standing alone without having to divide by any number. Okay, so whatever we have here is equal to our x, and that is what? 4. So our x is what? Is 4. So 3x plus 1 equals to 2x plus 5. The condition or the value for x that will make the equation accurate is what? Is 4. If you have to put in 4 over here, we should get the equation right. So that's it for the 6th one. And the 7th one, let's get the 7th question. We have 2x minus 3 equal to 7 minus 3x. So 2x minus 3 equal to 7 minus 3x. Okay, so we have negative 3x here. So ideally, negative moves here. So we have a positive value. So we have, and then I think at this point, you can move together, you can move concurrently. So let's move this negative 3 here, and then let's move the negative 3x also over here. So negative 3 is going to the right hand side, negative 3x is coming to the left hand side. So then we are left with 2x plus 3x. That's because there's a negative sign here. It moves and becomes what? Positive. So there's the line for that. Okay, so it becomes positive. And then the negative, let's go to the other side. You have 7. Negative 3 moves and becomes what? Plus 3. So we have 5x is equal to what? 10. Okay, so this becomes our expression that we have. So 5x equal to 10. We divide both sides by 5. We are left with x is equal to what? 5 or 10 divided by 5. That is what? 2. So that becomes our what? Our answer for number 7. Okay, so this is a quick look at how to solve questions. Some questions under what? Under linear equation. So if you are variables, or if you have the same variable on both sides of the equation, what you do is what? You move the variables to one side, then you simplify it, then you equate it to whatever value you get for it, the constant. Then if you are supposed to divide or whatever they're supposed to do to get the variable to stand alone, you do it, and then you have your answer right there for you. So that's it for the first set of questions. Now let's look at some questions that we have over here. So now we look at the linear equations involving brackets. Linear equations involving brackets. Okay, so these are a set of questions that have a bracket fused into the equation. Okay, so for number 1, we have 3 into bracket x minus 2 equals x plus 8. 3 into bracket x minus 2 equals x plus 8. And number 2, we have 5 into bracket x plus 2 equals to 2 into bracket 2 minus 2x. Now let's quickly look at how this is done. So these are new sets. So number 1 for this, we have 3 into bracket x minus 2 x plus 8. So there's nothing new about this. Okay, if you know what the bracket stands for, then there's nothing new about this. Okay, you only know that the bracket stands for multiplication. Not just multiplication, means that the number in front, the number that precedes, multiplies every single term within the bracket. Okay, so knowing that, it means 3 multiplies x and then 3 multiplies negative 2. So we go like that. So we have 3x and then 3 multiplies negative 2 minus 6 is equal to what? X plus 8. So this is a new equation, or this is the equation we deduce from this. So at this point, we just revert to what you already know. We move all the x to one side. We move all the numbers to one side. So we have 3x minus x to be equal to what? 8 plus 6. So 3x minus x equal to 8 plus 6. Now give us 2x equal to what? 14. At this point, you divide both sides by 2. We have x to be equal to what? 7. So that's it for the first one. So 3 into bracket x minus 2 equals x plus 8. If you have to go ahead, 3 will multiply x, 3 multiply negative 2. We have our answer to what? 7. So that's it for the first one. Let's look at the second one. For number 2, we have 5 into bracket x plus 2 to be equal to 2 into bracket 2 minus 2x. So what do we have here? So 5 multiplies x. So it multiplies every term every term within the bracket. So 5 multiplies x, and then 5 multiplies plus 2. So we have plus 10 for that. Then we come here, 2 multiplies 2, we have 4. 2 multiplies negative 2x, we have minus 4x. So what then do? We move all the x to one side, all the numbers to one side. We have 5x. Negative 4x comes here, we have plus 4x. because of the negative sign. We have 4. The positive 10 comes and becomes a negative what? 10. Okay, so we have 9x to be equal to what? Negative 6. We divide both sides by 9. Then we have x to be equal to what? Negative. We can go ahead and divide this to have 2 over what? 3. So negative what? 2 over 3. So that's the value of x that will satisfy the equation. So that's it for the second one. So the only thing is what? You open up the bracket, then we have an equation without the bracket. Then because there are variables on both sides, we move them to one side. We keep the constant on one side, and after that we equate it to find, we equate and we simplify, then later we get a final answer. So that's it for the second one. Okay, now let's go to I think we have some other examples to look at. Okay, so we have 3 and 4. We have example 3. 6 into bracket 3x minus 4, the bracket close. Okay, so 3x minus 4, bracket close, is equal to negative 4 into bracket x plus 6. So let's look at this. We have 6 into bracket 3x minus 4 equal to negative 4 into bracket x plus 6. Okay, so let's open this up first. We have 6 times 3x, that's 18x. 6 times negative 4, that's minus 24. Should be equal to negative 4 times x, that's negative 4x minus 24. Okay, so you have, surprisingly, you have negative 24 on both sides. Okay, so what we do is we deal with the x's. X comes to the side, the positive values move to, or the constants move to the other side. So we have 18x plus 4x equal to negative 24. Negative 24 over here moves there, becomes what? Plus 24. So what do we have? We have 0 over here. So negative 24 plus 24 is 0. So we have 22x equal to 0. But then because it's 0, okay, let's just go ahead and divide both sides by 22. It doesn't change anything though. X is what? 0. So anything, 0 over anything is what? Is 0. Okay, so our x over here is what? 0. So let's try it and see if it will work over here. So 6 times 3 times 0 give us 0, right? So 6 times negative 4, that's negative 24. I mean, that's what we have over here. Negative 4, x is 0. So okay, so 0 plus 6 is what? 6. So 6 times negative, we still have negative 24. So actually that's it. So the 0 that we found is actually true. Okay, now let's look at the fourth one. The fourth question. We have 4 into bracket 2x plus 3 minus 7. That's on the left hand side of the equation. To be equal to 7 plus 3x minus 6. Okay. So in this case, okay, let's just go. So we have 4 into bracket 2x plus 3. Let's multiply through, or let's go ahead. So we have 4 times 2x giving us what? 8x plus 4 times 3 giving us 12. Then we have a minus 7. This is not included in the bracket, so it doesn't, the 4 doesn't really affect, the 4 doesn't affect it, so it's standing on its own. So whatever we get here, we come and add it to it after we are done. Okay, just like that, we have 7 over here plus, there's no number here, so we can open a bracket, or we can assume it's 1. However you take it, the values here retain the original value. Okay, so the numbers here retain the original value. So we have 3x minus 6. If we had a negative sign over here, the probably it would affect the negative here, but then it's positive, so positive times negative is still negative, so we still have 3x minus 6 looking the way it is over here in the bracket. So we have 8x plus 12 minus 7. Okay, so let's see if you can do a bit of calculation over here. We simplify this before you move it, and let's simplify this before you move it. So 12 minus 7, so let's say we have 8x plus 12 minus 7, that's 5, equal to, so let's say 7 minus x, that's 1, plus 3x. We can only add the constants. Okay, you can only deal with add the variables, was they are similar or they are common. Okay, now let's move 3x to the side, and let's move 5 to the other side. So we have 8x minus 3x being equal to 1 minus 5, because the positive becomes what? Negative. So we have 5x being equal to what? Negative 4. We divide both sides by 5 by 5. So we then have x equal to what? Negative 4 over 5. So that becomes our answer for the fourth question. So this is how to deal with linear equations involving brackets. Okay, so now let's get another set of questions that we want to look at. The ones involving fractions. Okay, so linear equations involving fractions. Okay, so now for an equation like this, we have 2x over 15 plus 1 over 3 being equal to 3. So the first thing we do is we make sure we get rid of what? The denominator. So we make the equation as in a straight line. Okay, so what we do is we find the LCM of the denominators. Okay, I think this is not the very first time we are doing this. So 15 and 3, realize that 15 becomes the LCM. So you multiply through by the LCM. That's 15. So 15 times each term of the expression. So we have 15 multiplying 2x over 15 plus 15 multiplying 1 over 3, then the same 15 multiplying the 3. So the mistake most of us do is that probably we multiply 15 by one set and then we leave the other part. Okay, so that will really cost us. So we multiply through by 15, so it cuts across. So 15 cancels out 15 over here, 3 cancels out 15, leaving it with 5, and we have 15 times 2 over here. So here we have 2x plus 5, that's 5 times 1, equal to what? 45. So this becomes our new equation. It becomes very easy to solve at this point. So we have 2x, we move the plus 5 to the side, giving us 2x equal to what? 45 minus 5. Then we have 2x being equal to 40. So dividing both sides by 2 will give us x to be what? 20. And that is it for this equation. Okay, so that's the x becomes what? 20 from our solution. Now let's get the second one also quickly. Okay, so let's get the second one, where we have 2x minus 1 over 3 minus x minus 2 over 4 being equal to 1. Okay, so this one we have. So let's look at the LCM. At this point, the LCM becomes 12. Okay, so we have 12 multiplying each set of the set of the expressions. Okay, so we have 12 times x minus 2 over 4. Then we have 12 times 1 over here. So 3 cancels out 12, we have 4. 4 cancels out 12, we have 3. 12 times 1, we have it there. So we have 4. But the mistake we make is sometimes you multiply the 4 by only the 2x. No. 4 actually multiplies the whole expression, 2x minus 1. But the whole thing is over 3. Okay, then we have 3 multiplying x minus 2 being equal to 12. So here we apply the knowledge we know under the brackets. Okay, dealing with the brackets. So that's what we are going to do. So 4 times 2x, you have 8x minus 4 minus 3x. That's minus 3 times x. Minus 3 times minus 2, that's positive 6, equal to what? 12. So let's simplify the variables and then deal with the numbers too. So we have 8x minus 3x, then you have minus 4 plus 6, equal to what? 12. So here minus 4 plus 6, you have positive 2 over here. Then we have 5x for this. So 5x plus 2 equal to what? 12. We move the 2 to the other side. We have what? 5x to be equal to what? 12 minus 2. And that'll leave us with 5x equal to what? 10. At this point, I'm sure you can tell me the answer. So we have our x to be equal to what? 2. Okay, so that's it for the second one. Okay, so x equal to 2. So now we've looked at expressions, or we've looked at equations with the variable on one side, the variable on both sides, the ones with brackets, and then the ones with fractions. Okay, so let's just take some questions, okay, to try or to test how much we really got today's lesson. Okay, so let's look at some questions. Okay, so on our screen we have 4 set of questions. Okay, so we have 1, 2, 3, and 4. test your understanding. So number 1, we have 3x minus 5 equal to, 3x minus 15 equal to 45. What you are supposed to do is find the value of x, like we've done in our solutions so far. So 3x minus 15 equal to 45, find the value of x. And then number 2, you have 2x plus 3 equal to 7 minus 3x. So you find the value of x over there too. Number 3, we have 3 into bracket 2x minus 1 plus 4 being equal to 5 into bracket s plus 4 plus 2. Okay, or 5 into bracket s plus 4 with brackets closed plus 2. Okay, so we find the value of x. We know how to go about that. And the final one, that involves fraction and also brackets, but I'm sure we can deal with that. So we have 2 over 3 into bracket s plus 2 equal to 1 over 4x plus 3. Okay, so 2 over 3 into bracket s plus 2 is equal to 1 over 4x plus 3. So you have to find the value of x. That will make the equation valid. Okay, so that being said, we come to an end of another interesting lesson today, and I really hope that you cleared your doubts on linear equations, and you'll be able to solve questions henceforth on linear equations. My name is Lord Apia Dankwa, and until I come your way again, it's bye for now. Stay safe. Bye-bye.